All right, so this week we are learning a whole bunch of different rules for dealing with exponents on variables. And today I'm going to be focusing on what happens when you are dividing things with variables. And these things with variables are, well, exponential expressions. So we'll start with just what we call exponential notation. So an exponent tells us that we have repeated multiplication. So if you have something b to the n, b has been multiplied together n times. So the exponent tells you how many things there are that are multiplied. So when we have exponents present on a term, basically, you don't even need to have variables. We call them exponential expressions because it has an exponent, and it's an expression because it doesn't have an equal sign if you just see like one of these. And so when we're simplifying these or evaluating these, we follow the order of operations just like we do for everything else. And with numbers, you basically just do the math, but with variables, we have some additional rules to follow. So the first rule is the multiplication property or the multiplication rule for exponential expressions. And this is where when you're multiplying things with exponents and the base, which is underneath the exponent, is the same thing, you can add your exponents together. So if you're multiplying 2 squared times 2 to the third, that's the same as 2 to the fifth, because when you expand it out, you're just counting how many 2's you have multiplied together. So you just recombine them. And so you add the exponents when you're multiplying. We are going to be focusing on dividing these. And so the opposite of adding would be subtraction. So when you're dividing exponential expressions, you subtract the exponents, and you always do it top minus bottom. If you do it the other way around, you're going to get the wrong answer. So you always have to do top minus bottom. And why does this work? So let's say we have 2 to the fourth over 2 squared. So if I expand that out, let me get my laser pointer here. So if I expand out 2 to the fourth is 4 2's multiplied together, and 2 squared is 2 2's multiplied together. So you have 4 2's on top, 2 on the bottom. And we can cancel things out. So you can see that we can cancel 2 on the top and 2 on the bottom, just like we cancel things with fractions. And that leaves us 2 left over, which is 2 times 2, or 2 squared. So that's the same as doing 4, the top exponent, minus 2, the bottom exponent, and we're left with 2 left over. So when we're subtracting exponents, it's like we're subtracting out what matches, and we are left with whatever is left over. So I've got 3 examples here. And when we say simplify, that means we're going to take something that is a fraction and we're going to rewrite it so it is no longer a fraction. We're going to simplify it. And simplify means if whenever possible, you try to get rid of the fractions. So we'll start with the one on the left. I have z to the fifth over z to the fourth. So we subtract the exponents top minus bottom. So this equals z, that's a really bad z, and you subtract 5 minus 4. So 5 minus 4 is 1, so it's equal to z to the first power, which we just write with our variable z. If we have an exponent of 1, we usually don't write it. In the middle, we have b to the 12th over b. So if you have a variable without an exponent, you can always write it as a 1. So we have b to the 12th over b to the 1. So when you're subtracting your exponents here, you're doing 12 minus 1. So this is equal to b to the 12 minus 1 in the exponent, which gives us b to the 11th. So if there's no exponent, it's not a 0, it's treated as a 1 for the exponent. And we can do this with numbers, just like I showed on the previous slide. So we have 2 to the 6th over 2 to the 4th. So you subtract your exponents top minus bottom. So 6 minus 4 is 2. So that gives us 2 to the second power. And then when we have numbers like that, we usually evaluate that 2 squared is equal to 4. So we won't leave it in its exponent form. We usually then actually do that math, because when it says simplify, that also means if you have any numbers, you evaluate those, you do the order of operations on the numbers. Are there any questions so far? Of course, my dog decides that now is the time for her to bark and be unhappy, even though I let her out just not too long ago. Okay, so those were the ones, you know, the simple ones where you do your division and then you pretty much have the answer. A lot of times I don't write the subtract that I'm doing. I just do the subtraction in my head. But when you're learning, it's best to write down the actual subtraction. So that way you know, see what's going on in your notes. So now we're going to get a little more complicated. So on the left here, I have in parentheses 2x to the 7th over, and then in parentheses 2x to the 3rd. So they have the same base. There's still 2x and 2x underneath the exponents. So we can still subtract the exponents. And our base is 2x. So we just have 2x in parentheses and then 7 minus 3, which gives us 2x to the 4th. And we're going to leave it like that because we haven't learned the rules to then deal with 2x to the 4th, because there are additional rules for that. Now the next two, they have multiple things going on here because we've got h to the 3rd, h to the 8th over h to the 7th. And then the other one has a multiplication on both the top and the bottom. So when you're simplifying something like this, we generally do the multiplication first, and then we do the division part. So we are going to use the rule where when you're multiplying, you add your exponents. So you simplify the top and the bottom first, and then you deal with the division. So on top, because we have h to the 3rd times h to the 8th, you add those exponents. So that's going to be h to the 3 plus 8 over h to the 7th. So 3 plus 8 is 11. So we get h to the 11th over h to the 7th. Then you use your division rule where you subtract the exponents top minus bottom. So that gives us h to the 11 minus 7, which is h to the, why am I having a brain fart? Doing this subtraction, I don't know why I'm having a brain fart with 11 minus 7, 4. So that gives us h to the 4th as our final answer. So we do it in this order for a specific reason, because if we try to do, like, let's say you try to do the subtraction, you would then ask yourself, I do 3 minus 7 and 8 minus 7? You know, do you subtract both of them? And the answer is no. You would only subtract one of them. And so to make it less confusing, you combine your multiplication first, and then you deal with that division. Now, the next one here, we've got two multiplications going on. We have w to the 12th and w squared. So those are multiplied on top. And then we have w to the 4th and w to the 5th, and those are multiplied in the bottom. So you're going to combine both of those multiplications going across. So we're going to add our exponents on the top and then add the exponents on the bottom. So we're going to do those kind of together. So we're going to have w to the 12 plus 2 over w to the 4 plus 5. So this gives us w to the 14 over w to the 9. So you simplify the tops and bottoms separately. Once you've got that done, then you're going to use your division where you're subtracting top minus bottom. So we're going to have w to the 14 minus 9, which use my calculator for, no shame. That gives us 5. So that gives us a final answer of w to the 5th power. So when you're simplifying these, you want to treat the tops and the bottoms of the fractions separate and simplify those before then you try to simplify the fraction itself. Are there any questions on these? Okay. So now we're ramping up. Now we've got multiple variables. So when we apply this rule, we have to match the variables. So you can't like combine your h and your k and then try to subtract. You can't like add those exponents because they're different variables. You have to match across the variables. And then when you've got numbers here, you just treat the numbers like anything else. You would try to reduce those or divide those. So you're going to, we've got this 36 h to the 5th, k to the 2 over 9 h cubed k. And you're basically treating them as separate. You've got your 36 over 9, and then you're going to kind of keep your h's together, and then you're keeping your k's together. And that k in the denominator has an exponent of 1 if there's no exponent written there. So you deal with your numbers and then you deal variable by variable. So 36 over 9 is 36 divided by 9, which is 4. So I can simplify that. And these results are all multiplied together. So that's going to be multiplied by the next part. So we got h to the 5th over h to the 3rd, and we're subtracting those exponents. So that's going to be 5 minus 3. And then we're going to simplify the k's. And that's going to be 2 minus 1, top minus bottom. So we get 4, h, and then 5 minus 3 is 2. And then k, 2 minus 1 is 1. So I usually don't write the 1. We will just write it as 4h squared k. So you keep it each, section by section, you treat the numbers, you match the variables, and you just, don't worry about the other things. You're just focusing on each part when you split it apart, and then you kind of recombine it into your final answer. So the same thing goes with the next one here. We have 15 m to the 5th, n p to the 12th over 4 m p to the 9th. So I'm going to group things together, the 15 over 4. So I'm going to just write that as a fraction, which that does not simplify. There, we don't have anything in common there. We can't reduce it. So it's going to stay as 15 over 4. Then we're going to group the m's together. So we have m to the 5th over m, and there's no exponent there, so I'm going to write a 1. Then we're going to have the n's, and there's an n on top, no exponent, so I can write a 1. But if there's not an n in the bottom, you can do an n to the 0 power because it's not there. So you can just put 0 for your exponent because there isn't an n there. And then we have p to the 12th over p to the 9th. So I'm just matching everything together. So then we go from left to right. 15 over 4 does not reduce, so we're going to leave it as 15 over 4. Then on the m's, you're going to subtract 5 minus 1. On the n, it's 1 minus 0. And then on the p, 12 minus 9. So we have 15 over 4, m to the 4th, n to the 1st, because 1 minus 0 is 1, and then p to the third. So that n to the first is kind of special here. I'm just going to kind of highlight it, because what I did is I wrote it over n to the 0. But you don't have to do that. You could just write n by itself, because you can see it didn't change. It's still a single n. I just wrote it over n to the 0 because then it kind of matches everything else we're doing. But the other thing you can do instead of writing n to the 0 is just to write it over 1, because there is nothing on the bottom. So you could write it that way, or you can just write it as n to the 1, because that's all you have on top. But, I wrote it as n to the 0 just so you can see how it's basically the same rule of everything else we're doing. You're taking this fraction, you're breaking it apart. It kind of just keeps it nice and organized. So you can write your answer as we have here, 15 over 4, m to the 4, n to the 1, p to the 3. Or what sometimes we do is we recombine it as a fraction, where the only thing in the bottom is that 4. So sometimes what we will do is put it back in fraction form. So it would be 15 m to the 4th n p cubed over 4. So it's the same thing as the 15 over 4 and then having it without a fraction. It's just when we're dealing with exponential fraction or exponential expressions, if we have a fraction, we usually like to put it all in that fraction versus having a fraction in front and then something else. Are there any questions? Okay, so here are a couple more. And the one on the right is a little kind of just to get your brain thinking. So on the left, I've got 15 w to the 5th, x to the 10th, y to the 3rd. And then we have negative 15 w to the 4th, x. So we're going to do the same thing we did before. We're going to split it up. So we've got 15 over negative 15. And then w, so I've got w to the 5th over w to the 4th. And then x, so I've got x to the 10th over x, and I'm going to give that a 1 since it doesn't have an exponent. And then y, so y to the 3rd, and then there isn't a y, so that's going to be y to the 0 because there's none of that. So 15 over negative 15, that reduces to a negative 1. And then w, I'm going to subtract 5 minus 4. Then on the x, 10 minus 1. And then on the y, 3 minus 0. So we get negative 1 w to the 1, x to the 9, y to the 3. And usually when we write this, we don't put the negative 1 there. We'll just use a negative. So we'd write it as negative w x to the 9, y to the 3rd. That's usually how we end up writing it. So any of those ones that we had, we usually don't put in the final answer. Now, the one on the right is to kind of get you thinking about what's going on. We have w to the 5n plus 3 over w to the 2n. So the same rule applies. You take the top minus the bottom. So this is going to be w, and then the top is 5n plus 3. and then we're subtracting 2n. So this is where it's really helpful to write down what's actually going on. Let's write down the subtraction like I've been doing. So you can see that on the exponent here, we have some like terms we can simplify. We can do the 5n minus 2n. So 5 minus 2 is 3, so that's 3n, and then we have a plus 3. And we can't combine those, so we can't do anything more with the exponent, and that's your final answer. So you may be wondering, why am I doing one with like the exponents with variables in the exponent? Well, if you don't have to go past this class, you're not going to see that. But if you have to go into college algebra, we are going to be dealing with variables in the exponent. So that's something that you'll see near the end of the course. And if you have to go on to algebra calculus, you're going to be dealing with this as well. You'll be having formulas with variables in the exponents that you have to simplify and things like that. So this is just to kind of give you a little preview of things you may see and how even when you have variables in the exponent, the same rules apply. And that's what's really nice about algebra, is that the rules apply whether it's a number or a variable. They're consistent. It's not like we have the rules apply in one area and not in another area. The rules are consistent. So if you see something you've never seen before, but you can think back, well, what have I seen that's similar to this? You can apply those same rules. So are there any questions? All right. Well, that is the end of what I had. So not a lot of examples to go through. It's pretty straightforward.